Today I am going to discuss the subject network analysis and synthesis. In this subject we are mainly dealing with networks and how to solve this network, that is their analysis, and to design different kinds of network. So this is basically a problem based subject. So for doing the problem you need to study some concept, some basic concept, then only it will be easier for you to do the problems or solve the network easily. So first we will learn some basics and then we will solve the networks by after studying certain theorems and all. So first we will start with the basics. First we will define what is a network. So we all are familiar with the components like resistor, capacitor, inductor, voltage source and current source. These five elements are called the basic circuit elements. The reason why they are called basic circuit element is that they cannot be subdivided further. So every behavior of the network can be represented by any of these five elements. So in some textbook they are mentioning operational amplifiers and transformers as also the basic circuit elements, but for the time being we are considering these five elements as the basic circuit elements. Now let us discuss what a network is. So here you can see two diagrams. In this a network is formed by interconnecting any of these basic circuit elements. So in these two diagrams you can see we have used the basic circuit elements like resistor, inductor, capacitor and voltage source. Here also the same components are used. The difference between the first and the second figure is that the first one here has an open path and the second figure has a closed path. So and once again I will tell, a network is formed by interconnecting any of these basic circuit elements. Now while studying the network theory we have come across another term also, circuit. So there is a minute difference between the network and circuit. The thing is that circuit is also a kind of network, but for a network to be called as a circuit, it should have at least one closed path inside it. So if there is at least one closed path, then such networks are also called as circuits. So we can say that every circuit is a network, but every network cannot be called as a circuit. So that is a basic difference between network and circuit. Now coming to the subject, network analysis and synthesis. So what do you mean by a network analysis and synthesis? So consider a network like this. Consider any network as we have shown like this. So every network will be having some input and some output. Input and some output. In most of the textbooks input will be called as input only, but in certain situations and certain textbooks input will be also called by another name, excitation. Output will be called as response also. So what do you mean by network analysis? Network analysis means we are given a particular network and this network is given a particular input. So if that is the case, you have to determine the output of the network. That is what is called as network analysis. And by network synthesis we mean that we will be given a particular input and we need some particular output. So you have to design a network in such a way that it produces this output for this particular input. That is called as network synthesis. Now let us discuss some basic terminologies that is coming that we are using throughout the subject. First one is charge. We all know that matter is made up of atoms, and we know that atoms contains we know that atoms have negatively charged electrons, positively charged protons, and electrically neutral neutrons. So atom contain negatively charged electron, positively charged protons, and neutrally charged neutrons. So this will be the inside the atom. The structure will be like this. It has a nucleus, and inside which there will be protons and neutrons, and outside in an orbit electrons will be revolving around this nucleus in an orbit, in a particular orbit. So this is the regarding the basic structure of atoms. So now an atom is said to be electrically neutral when, because the positively charged protons and electrically charged electrons, negatively charged electrons will be balanced. So then an atom is said to be electrically neutral. So now we will discuss the unit of charge. Unit of charge is coulomb, Coulomb, coulomb. So 1 coulomb means it is a charge of 6.24 into 10 raised to 18 electrons. 1 coulomb is equal to the charge contributed by 6.24 into 10 raised to 18 electron. And now if that is the case, what will be the charge of 1 electron? The charge of 1 electron will be minus 1.602 into 10 raised to minus 19 coulomb, and charge of 1 proton will be plus 1.602 into 10 raised to minus 19 coulomb. So the magnitude of the charges of electrons and protons will be the same. The only difference is in their polarity. Next is current. Current is produced by the movement of charge carriers. So when the charge carriers move, it will produces a current. So the textbook അല്ലെങ്കിൽ the technical definition of current is the rate of flow of charge carriers is what is called as current. So the rate of flow of charge carriers is called as current, and current is given by the equation Q by T, or instantaneous current will be given by the equation Q by T. All the DC values will be represented by capital letter I, and AC value will be represented by small letter I. So current is, the unit of current is, or the current is measured in amperes, and it is represented by capital letter A. So suppose the electrons are moving in this direction. Suppose the electrons are moving in this direction, then the direction will be direction of the current will be taken as opposite to the direction of the movement of electrons. Current will be of basically two types: DC, direct current, and AC, alternating current. Now we will see what a direct current and what an alternating current indicates. So direct current or DC. What do you mean by a direct current? We can see from the graph, which is plotted with a time on the x-axis and current on the y-axis. In this graph, you can see that the direction as well as the magnitude of the current is constant. Right? So this kind of current is known as direct current. In direct current, the magnitude and direction will not change. It will be constant. Now we will discuss what an alternating current. That is, we have plotted time t on x-axis and the current I on y-axis. If you see the graph, you can see that the magnitude has both positive and negative side. Also the direction is also changing. So in AC current or alternating current, the magnitude as well as the direction of the current is changing with the time. That kind of current is called as alternating current. So let us discuss what a voltage is. So voltage between any two points A and B is the amount of work required to move a unit charge from point A to point B. We all know that there will be a force of attraction between the unlike charges and force of repulsion between like charges. To move a charge from one point to another, we have to overcome this force of attraction. So for that we need to do some work. So voltage is the work required to move a charge from one point to another point. So the equation of voltage is given by W by Q, where W is the work and Q is the charge, and unit of voltage is volt, and it is represented by capital letter V. It is represented by the capital letter V. So voltage is also called as potential difference also. So a current will flow only if there is a potential difference. Current will usually flow from a higher potential to a lower potential. So now let us discuss what power means. Power is the rate of doing work. So it is given by the equation P is equal to W by T, and the unit of power is watts, and it is represented by W. So we always know that consider our electric bulb. We have the specification of electric bulb is like that 100 watt or 60 watt like that. It means that that particular device can handle a maximum power of 100 watt or 60 watt. Beyond that, the device will get damaged. So in certain cases, the specification will be given in the terms of power. So it is necessary to learn or study what a power is. So this can also be written as P is equal to dW by dt, which can also be written as dW by dq into dq divided by dt. So both of these will be same, because if you cancel dq by dq, it will be same as dw by dt. So we have already studied that work divided by charge is given by voltage, and this would be the value of current. So the equation for power will become P is equal to V into I. This is a very important relation, and this gives the value of the instantaneous power. Throughout this subject, we will be using this equation or different forms of this equation, which we will discuss later. So instantaneous value of power is given by the product of instantaneous value of voltage and instantaneous value of current. So there will be different sign conventions for power absorbed and power delivered that we will discuss when we do the problems. Now if we discuss that, you will get more confused. So we will discuss it when we do the problems. Now let us discuss what energy is. Energy is the measure of capacity of doing work, that is how much work we can do. It is called as energy, and energy is given by the relation power into time that we have derived from the previous equation. Energy is equal to power into time, and energy is always measured in joules, or another unit is watt second. The unit of power is watt and unit of time is second. Therefore another unit is watt second. So while discussing energy, we have to deal with energy consumed. So consider our current consumption or electricity bill. So there they are measuring the amount of power consumed by the customer or consumer in a particular period of time, say 1 month or 2 months. So in such cases, the energy consumed will be measured in watt hour. So watt hour will be the unit when we measure energy consumed. So 1 watt hour is equal to 3600 joules. While discussing the topic voltage, I forgot to discuss about DC, the types of voltage. There are, like the current, there will be DC voltage as well as AC voltage. So the same thing applies here also. DC voltage have a constant magnitude and direction. It does not vary with the time. But whereas AC voltage, in case of AC voltage, the direction as well as the magnitude will be varying with the time. So DC voltage means the voltage supply from battery and all, and in the household supply we will be getting AC voltage. So these are about the fundamental terminologies coming in this subject. Now we will discuss some problems related to these topics, so that the topics will be more clear for you. It is not necessary that these kind of problems will come for the exam, but so solving 2-3 problems will make the concept clear. So now let us start doing some problems. The first question is, an initially neutral body has 1.7 microcoulomb of negative charge removed. Later, 18.7 into 10 raised to 11 electrons are added. What is the final charge of the body? So in the question, they said that they are saying that initially there was a neutral body, and from the neutral body we have removed minus 1.7 microcoulomb of charge. Later we have added 18.7 into 10 raised to 11 electrons into that body. So if that is the case, what is the final charge of the body? So how we will do that problem? Let us see. So Q initial will be what? 0, because it is said that it is neutral. Neutral, Q initial mean neutral in the sense that both the negative charges and the positive charges are balanced. So atom doesn't have any charge, that is, it is neutral. That is why we have taken Q initial as 0. From that we have removed 1.7 microcoulomb of negative charge. So if from this body will be having equal number of positive and negative charges. So from this body, if we are removing 1.7 microcoulomb of negative charge, then what is the charge of that body then? It will be having now plus 1.7 microcoulomb. Okay. Then it is said that we are adding 18.7 into 10 raised to 11 electrons into this body. So we have to determine what is the charge of 18.7 into 10 raised to 11 electrons. So charge of one electron is 1.6 into 602 into 10 raised to minus 19. So therefore for 18.7 into 10 raised to 11 electron, the charge will be minus 1.602 into 10 raised to minus 19, and that will be 0.3 microcoulomb. So when you do it in the calculator, you will be getting the charge as 0.3 microcoulomb, sorry, minus 0.3 microcoulomb. Now this minus 0.3 microcoulomb is added to this charge. So what will be having? 1.7 plus 1.7 microcoulomb minus 0.3 microcoulomb, and it will be plus 1.4 microcoulomb. So if you are writing for the semester examination, make sure that you are writing the unit also, otherwise you will lose the mark there. Now let us do the second problem. To move a charge from point A to point B requires minus 30 joule. So find the voltage. So we are asked to find the voltage, and we are given the value of energy required to move a charge from one point to another. So this can be easily solved if we remember the basic definition of voltage. So what is the relation for voltage? Voltage is equal to W by Q. So we are given the value of W, and sorry, there is a small part for the question. If Q is 2 coulomb, and second question is if Q is equal to minus 6 coulomb. So in the first case, then V will be equal to, what is the energy? Minus 30 divided by Q will be 2 coulomb. Therefore it will be 15 volt. Second case, when Q is equal to minus 6. Same relation, V is equal to W by Q, and in the place of W we will be substituting minus 30, and here the Q will be minus 6 coulomb. Therefore it will be minus 6. Therefore answer will be 5 volt. So this much amount of voltage is needed for the charge to move from point A to point B. Now the third question is, an energy source forces a constant current of 2 ampere for 10 seconds to flow through a light bulb. If 2.3 kilojoule of energy is given off in the form of heat and light, calculate the voltage drop across the bulb. So we are asked to calculate the voltage drop across the bulb. So we are given the energy and we are asked to calculate the voltage drop. So we know that voltage, from the basic definition, voltage drop is given by the equation W by Q. So W is already there but Q is not there. But instead of Q, they are given current and time. So Q will be equal to what? Q is equal to I into T, and that will be 2 into 10. That is equal to 20 coulomb. So substituting that value here, it will be 2.3 into kilo means 10 raised to 3. 2.3 into 10 raised to 3 divided by 20, and that will be equal to 115 volt. Now the next question is, how much energy does a 100 volt electric bulb consume in 2 hours? So here we are asked to calculate the energy consumed. So we know the basic equation of energy is power into time. Here power is given as 100 watt and time as 2 hours, right? Here we are not going to change any unit into unit of time into second and all, because we have already studied that energy consumed will be calculated or measured in terms of watt hour. So this will be equal to 200 watt hour. So if you want to convert this into joules, what you will do? 200 into 3600, that is 720000 joule, and this will be equal to 720 into 10 raised to 3, that is equal to 720 kilojoules. This will be the answer. 10 raised to 3 means kilo, so 720 kilojoules. Now let us discuss the last question. Find the power delivered to an element at t is equal to 3 millisecond if the current entering the positive terminal is I is equal to 5 into cos 60 pi t given. I are asked to find the power if the voltage V is equal to 3I and V is equal to 3 into di by dt. So first we will start with the first question. V is equal to 3I. So here you are asked to calculate the power. So we know the equation of the power is given by P is equal to V into I. But V is given as V is equal to 3 into I, where I is 5 into cos 60 pi t. So V will be equal to 3 into, the value of I will be 5 into cos of 60 pi t. That will be equal to 15 cos 60 pi t. So substituting the value of V in this equation, we will get, V will be 15 cos 60 pi t. 15 cos 60 pi t into, the value of I will be 5 cos 60 pi t. And therefore the answer will be 15 into 5, 75. 75 cos 60 into cos 60, cos squared 60 pi t. Now while doing this, 75 into cos squared into 60 into 180 into, for value of t, you are asked to calculate the power delivered at t is equal to 3 milliseconds. So for the value of t, you have to substitute 3 into 10 raised to minus 3. Okay. So on solving this, you will get the value as 53.48 watt. So if you are using the scientific calculator, while calculating this, you have to set the calculator in the degree mode, then only you will get the answer correctly. So 53.48 watt. Now we will do the second one, when V is equal to 3 into di by dt. So second one, V is equal to 3 into di by dt. So d by dt of, instead of I, you will have to substitute 5 into cos of 60 pi t. So what you will get, 5 is a constant, so you have to take that outside. 5 into d by dt of cos of 60 pi t. The differentiation of, when you differentiate cos, you will get minus sine. Therefore it will be 5 into minus sine 60 pi t into, then you have to differentiate separately the coefficient of t. Therefore it will be 60 into pi, right? Therefore the answer will be minus 60 into 5 means 300, minus 300 sine 60 pi t. Therefore voltage is 3 into di by dt. Therefore V will be minus 900 sine 60 pi t. Now what you have to do, you have to substitute the value of V in the equation of power. So P is equal to V into I. Therefore minus 900 pi into sine, sorry, here you have one pi value is there, sorry, pi. So 900 pi into sine 60 pi t into, the value of I is 5 into cos 60 pi t. So this will be 9 into 5, 45. Therefore minus 4500 pi into sine 60 pi t into cos of 60 pi t, and that will be also minus 4500 into, for the pi you have to substitute the value 3.14. 3.14 into sine of 60 into 180 into 3 into 10 raised to minus 3 into cos of 60 into 180 into 3 into 10 raised to minus 3. That will be equal to, so when you solve this, you will be getting the answer as minus 6.392 kilowatt. Minus 6.392 kilowatt. So this will be the answer. So by this we have discussed what a network is, what is the difference between network and circuit. We have discussed already the fundamental terms like charge, current, voltage, power, energy, and for whatever contents we have discussed, we have discussed the problems associated with that also. The intention of this class is not to educate, not to teach you very high level things. We will slowly start with the basic things, then gradually we will move on to the advanced concepts, so that even an average student can solve the network problems easily. So in the next class we will be discussing the basic circuit elements, and we will do some small problems associated with it. Thank you.